let's take a look at an example dealing with continuity. So our example is this. Let f of x be defined in this way, right? So it's x times sine of 1 over x whenever our value of x is not 0, and then it's 0 whenever the value of x is equal to 0. We want to prove that the limit as x approaches 0 of the limit of the function at 0, that limit is equal to 0. Now you might say, I thought you said at the beginning of this video that we were going to look at an example dealing with continuity, but now we're just proving something about the limit. And so, how do you reconcile those two things? Well, I reconcile those two things because that's true, we are going to prove this limit, but with that limit, we can also make this kind of side observation that the value that we are saying when x is approaching 0, that our limit is 0, we also can observe that that is the function value. And so when we go through this, we will actually have shown, when we show that this limit is 0, we will actually have that the function itself is a continuous function when we define it piecewise in this way. All right, so let's prove this. Let epsilon be greater than 0. And then let delta be equal to epsilon. Then if we have the absolute value of x minus 0 is less than delta, this will imply that the absolute value of x is less than epsilon. But we can also make this other observation. We can make this observation that x times the sine of 1 over x, sine of 1 over x, that's going to be oscillating between -1 and +1, right? And so it's it has an absolute value that's no larger than 1. So the absolute value of x sine of 1 over x should always, always, always be less than or equal to the absolute value of x. So we have the absolute value of x sine 1 over x minus 0 is less than epsilon. Therefore, our limit of f of x as x approaches 0 is actually equal to 0. It is also equal to f of 0, and so we also might note f is continuous at x equals 0. Beautiful. All right, so that is our proof. So we can prove that that function is continuous. Pretty straightforward. We will talk to you again and take a look at another example in our next video.